Hello, class. Today we are going to go over section 4.1, graphing systems of linear equations. So in order to be able to do this section, we first need to know what a system of linear equations is. Well, a system is a group, and it's a system of linear equations. So a group of equations of lines. Okay, and there can be two or more equations. So it's a group of equations of lines that we're looking at together. The solution to the system is an ordered pair x comma y, where the lines intersect. So you find the point of intersection, and that is your answer to these problems. Now, first we're going to start with examples where we're looking to see if a point that they gave us is a solution to a system. So this is kind of like checking your answer to make sure it works. Okay. So in this first problem, they give us -10 comma -8 as our answer. -10 is our x value, -8 is our y value. We're going to plug those numbers in for x and y into each equation and simplify to see if it checks out. So it's just like when you would check your answers on solving equations. So for this first equation, 2x minus 5y equals 20. I'm going to replace x with -10, so 2 times -10 minus 5 times my y I'm going to replace with -8 equals 20. And I'm going to simplify that left-hand side. So 2 times -10 is -20. -5 times -8 is +40. -20 plus 40 is 20. So both sides do end up being the same number, which means this problem works. For the next one, we have the point -7 comma 4. Oops, I'm sorry, we need to back up because I did not yet check the second equation in that first example. So I can't just check one equation, I have to check both because it's possible that it works in one and not the other. So we need to check -10, -8 in the equation -x plus 2y equals -6. So I'll put the negative in front. I'm going to replace x with -10 plus 2 times, replace y with -8 equals -6. The double negative becomes a +10. 2 times -8 is -16 equals -6. Well, 10 minus 16 is in fact -6, and it works there. So the directions said to tell whether it's a solution. Since it worked in both of these equations, the answer is yes, it is a solution. So you would want to write yes at the end. Now we're actually done with that problem. The next problem is the same in that we are going to use the point they gave us, -7 comma 4, to replace x and y and see if these check out. So for the first equation, 2x plus y equals -10. I'm going to replace x with -7. So 2 times -7 plus, I'm going to replace y with 4, and we're going to see if that equals -10. Well, 2 times -7 is -14, plus 4 equals -10. -14 plus 4 is in fact -10, so it works in the first equation. Now we have to see if it works in the second equation. Y equals -x plus 11. So I'm going to replace y with the 4 equals, I'm going to bring down that negative sign that was in front of the x, and then I'm replacing x with -7 plus 11. So then I write 4 equals, negative and a negative become a positive, so it's 7 plus 11. So I get 4 equals 18. That is not a true statement. Since that's not true, it didn't work, so our answer is no, this is not a solution. Now we're going to move on to figuring out how to solve these systems, how to actually find those points of intersection by graphing. Okay, so for this next example, we're going to graph those two lines and then see where they cross. For the first line, y equals x plus 3. Remember, our slope is in front of the x, so for our slope, we're going to use a 1. Okay, since it's not there, anytime the number's not there, it's a 1. For our y-intercept, we're using the plus 3. So that means I go up 3 on my y-axis and plot a point. That's my y-intercept. My slope is 1, so I go up 1, right 1, up 1, right 1. And I continue that pattern. For this first line that you graph, you do want to extend it in both directions as far as it'll go because you don't know where these lines are going to intersect. So I am going to go back to the y-intercept and I'm going to go backwards. So instead of going up 1, right 1, I'm going to go down 1, back 1. And that gives me the rest of this line. Now I'm going to go ahead and graph the next line. So the next one is y equals 1/2 x plus 2. For this one, our slope is 1/2. Our y-intercept is 2. So I'm going to go to 2 on the y-axis and plot a point. Then I'm using my slope of 1/2. So I'm going to go up 1, right 2. Well, if I keep going that direction, up and right, I'm not going to intersect the blue line. So instead, I'm going to go back to the y-intercept. I'm going to go the opposite direction. I'm going to go down 1, back 2. If I do that, I do intersect the blue line at this point here. So that point is our answer. And that ordered pair is -2, 1. So your answer is the point, -2, 1. Now, the great thing about this chapter is you can always check your answers by plugging them into the original problem. So that's what we're going to do over here where it says check. I'm going to take that first equation, y equals x plus 3. I'm going to replace y with what we got. So I'm going to do 1 equals, replace x with what we got, -2 plus 3. So I get 1 equals, -2 plus 3 is in fact 1, and it works in the first equation. Now let's make sure it works in the second one. Y equals 1/2 x plus 2. So I get 1 equals 1/2 times -2 plus 2. Y equals half of -2 is -1. -1 plus 2 is 1. And it worked in that one, so that means we did it right. If your checking didn't work out, that means either you didn't simplify correctly in your checking or you graphed your problem wrong, and you'll need to go back and look and figure out what you did wrong. All right, for our last example here, we have x minus y equals 5 and y plus 3 equals -3 times x minus 2. So let's go ahead and graph the x minus y equals 5 first. In order to graph it, I am going to rearrange it into slope-intercept form just to make finding the intersection a little easier. So to get y alone for slope-intercept form, I first need to move the x. So I'm going to subtract x from each side. This leaves me with the -y equals, I'm going to put the -x, and the 5 is positive, so I put a +5. Now, to get y completely alone, I need to get rid of the negative. So I'm going to divide everything by -1. That gives me y equals positive x minus 5. So I'm going to graph x minus 5. That means my y-intercept is -5. So I'm going to go down 5, 1, 2, 3, 4, 5, and put a dot. And my slope is 1 since there's no number listed in front of x. So that means I go up 1, right 1, and I continue that pattern. I can also go down and back. Now that second equation is in point slope form. So for point slope form, you actually don't have to rearrange it to graph it. You have all the information you need within that equation. Okay, it's just a little different than slope-intercept form. So what's different is your starting point. For your starting point, you'll use the opposite of the value next to x for the x value in your point. So for x value in our point, instead of using a -2, we'll use a +2. For your y value, use the opposite of the number here after y. So instead of using a +3, we'll use a -3. So our starting point is 2, -3. The slope is still the number in front of x, so the slope will be -3. Okay, so I'm going to plot my starting point, 2, -3. So I go right 2, down 3. And look at that, it ends up being our point of intersection. Now I am going to put at least one more point on that line, just so we can show that we graphed both lines. So I'm going to use the slope of -3 to go down 3, right 1, so that I have a line there and can show that it's a point of intersection of those two lines. Okay, so our answer for this problem is 2, -3. We can check it to make sure we did it right in both of the original problems. So for the first original problem, x minus y equals 5, I'm going to replace x with 2, minus, then replace y with -3, equals 5. The two minuses become a plus, so 2 plus 3 equals 5, 5 equals 5, so that checks out. Now let's try it in the next equation. Y plus 3 equals -3 times x minus 2. I'm going to replace y with -3, so -3 plus 3 equals -3 times, replace x with 2, minus 2. Well, -3 plus 3 is 0, equals -3 times 2 minus 2 is 0. So I end up getting 0 equals 0, which is also true. So we did this correctly, and our answer is in fact 2, -3. So that's it for this problem. That's also it for notes today. If you have any questions, be sure to contact your teacher.